This video tutorial is on how to solve the gas laws, but where you have to identify which gas law you should be using based on the variables that are given to you. Okay, so if you look at the first problem in the assignment, it says a gas in a sealed container has a pressure of 125 kilopascals, which I put right there, and a volume of 5.4 liters. There it is. If the pressure in the container is increased to 201 kilopascals, here we go, what is the new volume? So the first thing I need for you to do is go ahead and identify what each of these numbers represent. So these are all your givens, and you're going to try and figure out what they are, and then what law you're using. Okay, so first we're going to figure out what they are. So if we look at your foldable, which I rewrote the information here, but in your foldable it says that if you have a number, in this case these two, that have kilopascals, then that's going to be your pressure. Okay, so it says that you had a pressure of 125 kilopascals, so that's the first pressure, and then it was increased to 201, so that's your second pressure. P1 and P2. Okay, and then it tells you that it has a volume of 5.4 liters. So there it's telling you it's its volume, but if you look at your foldable, you'll also know that the volume comes in milliliters and liters and centimeters cubed behind the number. So that's your first volume. It's asking what is the new volume. So we don't know what the new volume is, so that's our unknown, what we have to look for. So that's V2. Okay, so we have pressure and volume involved in this problem. So now, looking at your foldables again, you're going to look at all the gas laws. And if you notice, Boyles Law deals with pressure and volume only, which is what you see here. If it were Charles' law, it deals with volume and temperature. If it is a combined gas law, it deals with pressure, with volume and temperature. If it's Avogadro's law, it deals with volume and number of moles. And if we were talking about the partial pressures, you talk about, or you would see moles and the total pressure being given to you. So in this case, we know that we are using Boyles' law. Okay, so here's Boyles' law and the formula, and we just substitute all the numbers that are in as our givens. So P1 is 125 kilopascals, so we write it there where P1 would be. V2 is our unknown, so that would be our X. 201 kilopascals, that would be our pressure 2, and then volume 1 is 5.4 liters. So at this time we're ready to solve it, in which case we're going to cross multiply. When you cross multiply, you want to multiply first the numbers that are not crossing with the unknown variable, which is V2. So we'll multiply 125 by 5.4. And then we're going to divide it by 201 kilopascals. Okay, so this is what it would look like. 125 times 5.4 divided by 201. Again, that one goes on the bottom because it is the one that cross multiplies with the unknown variable. For your answer, whenever you come up with your final answer, which you're going to calculate, make sure that you have the right unit, and to figure out what the units are, cancel those that repeat. Like kPa repeats here, so they get crossed out. The only one that doesn't repeat is liters, and which is what you're trying to find. You're trying to find volume, so your answer is going to be in liters. Okay, for the next problem, it's pretty much the same concept. So you're having to go through and find out which each one is. Okay, so this is in liters, and as we said earlier, if it's in liters, looking again at our notes, we know that liters is going to be volume. So that's going to be our first volume mentioned. And if we read to it, it says the Celsius temperature of a 3-liter sample of gas. So 3-liter sample of gas is lowered from 355 Kelvin to 303. Okay, in this case, there was a mistake. It was not. It was converted to Kelvin already, so it should have read the Kelvin temperature, or just the temperature. Okay, so as we look at this, we know that this is our temperature 1, and this next one is our temperature 2. Okay, at this point, we don't know what we need to find, so we'll read on. It says, what will be the resulting volume? So we're looking for volume 2, coincidentally again, which is what we searched here. But this time around, you're not given pressure and volume, you're given volume and temperature. So those are the two main variables, volume and temperature. So you would go and look at all your possible formulas. Remember that Boyles Law deals with pressure and volume. Charles' Law deals with volume and temperature, which is what we see here. If it were combined, we'd see pressure, volume, and temperature, and if it were Avogadro's, we'd see volume and moles. So it would be safe to say that we're dealing with Charles' Law. Okay, and just like before, we know that we substitute the numbers for the variables. We cross multiply. So in this case, it would be 3 times 303. They go on the top because they're the ones that do not cross with the unknown. But now the one that crosses with the unknown, just like we did in the top, always goes on the bottom as a rule of thumb. Okay, so then for our answer, if we cancel Kelvin with Kelvin, we're left with liters, which is what our remaining unit will be. So now all you have to do is calculate your answer. Okay, for the third problem, if you notice, we're given moles now. And if you look at your foldable, I had you write down what every variable stands for. So P is for pressure, V is for volume, T is for temperature, N will be for moles. So in this case, 10.55 moles, our variable is N. Okay, there's no other moles. It could be our unknown, but we keep going. But that's our first N given to us. And then we notice that it has 12.55 liters. Okay, for liters, we already established that that's volume. And then we have 345 K, which is Kelvin and temperature. So we know that that's temperature. And notice that we don't know what this could be, and there's only one N, only one V, only one T. So if we look at our formulas, we're going to look for those formulas that have moles, volume, and temperature. So this one doesn't have moles nor temperature. This one doesn't have pressure nor moles. This one doesn't have moles, but it has pressure, volume, and temperature. And then this one has moles and it has moles and volume. And there's one that's missing, and I'm going to add it. Okay, and here it is. PV equals nRT, which is the ideal gas law. So it has volume, it has temperature, it has N for moles, and the only one it doesn't have is R, but R is a constant. It will never change from what it is. So I'm going to go ahead and write down what R is. And it's also found in your foldable. Okay, this is a value for R, and like I said, if you see R in the problem, like you do here, and that's pretty much the only problem or the only formula you're going to see it in, it's always going to be this number. So you're not looking for it, or nor will it be given to you, because it should always be this number. So it's going to be 0.0821 liters times atmospheres over moles times Kelvin. This is not a formula, this is a unit just for that number. So looking at what we have here, we have pressure, no, volume, yes, N for moles, yes, R, that's already understood as always being that number, and temperature, yes. So that must mean that our unknown is going to be pressure, and we're using the ideal gas law. Okay, so going back, we see that here's the substitution for all of them. Here's pressure, this is volume, this one is N, which is moles, we're just substituting the number. Here's R, our constant, which is always going to be the same number, and then here's our temperature, which is 345. Now if I take all the units off just to make it less confusing, this is what it looks like. So, and then I also put the P behind the 12.55, kind of like if it was 12.55x. So 12.55 P is equal to 10.55 times 0.0821 times 300, and actually I put 54, but it's 45. And it looks like this. Okay, so if we simplify this even more by multiplying all three numbers, we get 298.82. By multiplying these three, we still have the 12.55 P. Now to solve for P, we need to get P by itself. So we're going to place this underneath the 298.82. So it's going to be 298.82 divided by 12.55. And you're going to go ahead and do the math there and then get your answer. Why is it in atmospheres? Because if you go back to the units that you had before, liters cancels liters, moles cancels moles, Kelvin cancels Kelvin, and the only unit you have left over is atmospheres, which is a unit for pressure and the one you're going to use. Okay, so on the fourth one, if you read the question, it gives you 12 atmospheres, 23 liters, 27 degrees Celsius, 14 atmospheres, 50 degrees Celsius, and they're asking you for the new volume, which is V2. These are all the ones that are given to you, or all the givens listed there. So now what I need for you to do is go ahead and identify the variable. Looking at your foldable, you'll find out that if a number has ATM, like it does here, that's going to represent your pressure. So that's the first pressure given to you. So that's P1. The second number also has ATM. So that's pressure 2. Okay, this one has Celsius, and if you're familiar with temperature, you know Celsius is temperature, but it can also be in Kelvin, so that's temperature. Something you must keep in mind is that you cannot use Celsius in gas laws. They all have to be in Kelvin. So it says to convert it to Celsius, or to Kelvin, I'm sorry, you have to add 273 to the Celsius number. So in this case, here's our temperature, or temperature 1, but we're gonna have to add 273 to it. So it's gonna be plus 273, and here's our second temperature, and you're also having to add 273 to that to make it in Kelvin. So that gives us 300 Kelvin and 323 Kelvin, which is what we're gonna use in the formula versus in Celsius. And then the last one is 23 liters. That's gonna be our volume as we established before. And then our unknown, if you notice, it's asking what is the new volume. So we're looking for volume 2. Okay, so we've got pressure, we've got temperature, and we've got volume. So looking at your foldable, the only formula that has all three is going to be your combined, well, I should take that back because ideal gas law also has a 3. But this one has 2 pressures, 2 volumes, 2 temperatures. So that's going to be your combined gas law. Okay, so here's the gas law, here's the formula. You substitute the numbers for the variables. P1, V1, T1 equals to P2, V2, and T2, V2 being our unknown. So you're going to cross multiply the same you did before, but now you have an extra number. Same, it works the same. The numbers that cross that do not have the unknown variable, which is your x, always go on top. So it would be 12 times 23 times 323 divided by the numbers that cross with the unknown. So these right here, which is 300 times 14. And that unknown, once you cross multiply, that goes on the outside as what you're solving for. So just multiply across, whatever your answer is, divide by what you get when you multiply 300 times 14. That's going to be your volume 2. For the unit, it's liters. How do we know? Because atmospheres cancels the atmospheres here, Kelvin cancels Kelvin, and the only unit that you have remaining is liters. Okay, for number 5, you have moles, which we done one with moles. And if you recall, moles is going to be the variable N. So this will represent the first N because you have another mole. This will represent the second N. We have a number in liters that represents the first volume. And your unknown, we can go ahead and look and read and see what they're asking. They're asking what would be the volume. So they're looking for the second volume. So now we need to find a formula that has moles and volume only. Okay, so we have moles and volume. So the one that has moles and volume would be Avogadro's law. Okay, so here's our formula where V1 is 3 liters and N1 is 8 moles. V2 is our unknown and 12 moles is going to be our N2. Okay, just like we've done in the past, we cross multiply. Remember what I said, the numbers that don't have the unknown go on the top. So 3 times 12 divided by the number that goes with the unknown on the bottom and the unknown on the side, which is what we're solving. So in this case, it would be 3 times 12, that answer divided by 8, and then that gives you your final answer. Make sure you find out what the variable is, or not the variable, but the unit, and keep in mind what I told you. If it repeats, it cancels, and if it's by itself, that's the one that goes here. Okay, now for the last one. It's giving you 3 moles of gas A, 7 moles of gas B in a container, and it tells you that the total pressure is 2 atmospheres. So there's no point in even trying to identify which gas law you're using, because it tells you what is the partial pressure exerted by gas A in the mixture. So right now we're only concerned with gas A. But remember that we have like somewhat of a little formula. You're going to get your individual moles. So you get your individual moles. In this case, our individual moles for just gas A, which is what they're asking, is 3, divided by the total moles. In this case, the total moles is when you add all the moles that are in the problem. 3 plus 7 giving us 10, multiplied by the total pressure, which is given to you in the formula in the question. The total pressure in the container is 2 atmospheres, so 2 ATMs. Okay, so for the answer for partial pressure of this, in this case, it says here X because we don't know what it is, but partial pressure of gas A would be 3 divided by 10 times 2, which gives us some answer in atmospheres. And then you solve.